Hello, I'm Professor Caudill, and today we're going to build off the last video. So last video we did performance enhancement software programming for video games. Now we're going to do it we're going to demonstrate it for a learning environment. To give you kind of how this video might go is I want to tell you a little bit about my background, how I developed this program. I'll demo the program, maybe show you how to get it to run for yourself. It's just like ChatGPT makes a lot of installation things easier. So, but yeah, the goal is to, one way to automate your intelligence by programming and getting for example, I studied some piano and I didn't discover how to improvise and get really good at it until I kind of master the basics. So if we're talking about mathematics, you might need to drill the basics, do the algebra, do the calculus by hand. I'm not entirely like that's the only analogy is why I see maybe some value in handwriting math. I can see arguments for both sides. I studied calculus at a local school in person, and the teacher, like the homework was online, but the final test was a handwritten test, and I did really poorly on the final test because I did all the homework and stuff by coding, and I didn't really handwrite. But I made the script as kind of like to drill problems by hand to get really good at it, and then I got better. So if you're taking calculus and your instructor really wants you to handwrite math, this might be a useful tool for you. Or you could take inspiration and build your own tools. So let's get into it. I'll go ahead and start by demoing it. So 4 lines of code. Zoom in. Okay, so when I run this, every time you see generating a new equation. So let's see what does this button do? If I select this, add to current page. Okay, so we have this problem. So like maybe you might want to solve this. So get my stylus. Okay. So, when I would do this, I posted a lot of videos or pictures on my Twitter of me I just do like 15 minutes a day, but you have your variable. So I think this is psi. So really you can separate this into two. So we're just gonna so it's really just because like you can generate really complicated equations, and I think one of the virtues of this script is it keeps it kind of bounded. I know other websites have done the same. What is that? -5. Okay, and it's gonna get a little long. Let me see if I can drag the screen this way. Okay. And let's see. Still using this Blackboard software, still getting used to it. And we're gonna take the derivative of this. So there's a lot here. I'm sure maybe some of you are overwhelmed. For the video's sake, let's just let's just do this part over here. Okay, so dragging has messed up my drawing tablet. Okay. Let's get this centered. Okay, there we go. Okay, so how are we gonna do this? So think of it like, let's just simplify it. So how do you do this? Well, let's look at a simpler case. Let's use a simpler variable. Let's say dx of, let's say this is a generic function of x. Okay, so I'm sure you probably have seen something similar to this. Okay, so so that would be that, and really that times, it's really two functions. You have to break it down. So you have to apply whatever rules of calculus. Off the top of my head, I should have like practiced this a little bit more before I started recording, but I know I think it's going to be like the derivative of this plus this times g of x. So I think that's what that would break it down into. I'm just kind of giving you like an abstract level. If you want me to like actually do this, okay, so let's say f of x, let's just say that's psi. And here we're just gonna say where x is psi. Okay, so now we're just gonna substitute these variables. So I just scroll down. Yes, okay, oh, that's nice. So what's the derivative of this? That's going to be, you can just rewrite it as 1/2. So you're going to pull out the 1/2 in front, and then it's going to be psi 1/2 minus 2/2 equals -1/2. So it's going to be, final answer is going to be 1/2 square root of that. Okay, so now you might wonder, okay, you generated a problem, you've kind of started to solve it. How can you check your answer? You know, it's kind of tedious. So we can look back at this and we can see maybe we got something. So you could see part of this answer, 2 square root psi. That's part of the answer we got. We obviously didn't do the whole thing. It generated a pretty big one. This is pretty like advanced example, but you can see how you can kind of check your answer with this. So let's go ahead and do this integral. Okay, let's try that again. Let's add this to a new page. There we go. Okay. So how would you do this one? So again, you can just break it up because it's this is an addition, so you can just kind of separate them. So let's just do this side. So integral cube root phi, sci-fi. I kind of just forget the names. I just kind of call them whatever sounds convenient at the time. So here we're just going to do the opposite. Rewrite it as O psi to the 1/3. And we're going to solve this. That's going to be so I know when you take a derivative, you pull it out in front. Here we're actually going to add it. We're going to add it first. So it's going to be 1/3 plus 3/3 equals 4/3. And now we're going to take this, we're going to add that in front, but it's going to be the reciprocal. So that's going to be 3/4 psi 4/3. And that's 3/4 times psi to the 4/3. Okay, so let's check our answer. 3/4 psi to the 4/3. So you see I've done part of that, and sometimes, especially with the tangent functions, I think I actually took them out because I thought it might have broke. Yes, I did take them out because I thought it might have broke with the new simplified version. But let's go ahead and see if we can fix this live. Okay. It had some weird error, so we're gonna save this. Okay, and now we're going to go back here. So these are all in one Jupyter Notebook directory. Okay, so like this is the whole code. Obviously, you don't want to run this every time. So now we're going to restart this kernel. Let's see if we can get some. Yeah, so there we go. Now we've generated some trig stuff. Now, obviously there's different trig substitutions, so sometimes you'll get the right answer, but it's not correct. So there's other websites, so you can copy the equation. I have it where it outputs it in plain text, and you can actually put it into another calculator. I don't know why it's saying eta instead of theta. His might be bugged. And if you in this you can actually pull up the steps to get a. The thing about this is you can't like. I don't think you can edit the code of this, so you can't like customize this if you really love this. I don't think you can. So that's why it's there, but this I think my tools may be a little more flexible. So yeah, when I studied some calculus, I have this is my GitHub 3 years ago. Let's pull up one. I would do the homework. Why isn't this displaying? I would do the homework, and man, now GitHub's breaking. That's a struggle with coding. It's the images I uploaded. Is it did ImageGer break my image? Okay, there it is. So it's not like the image is there. Like the link's not broken. It's just GitHub's broken. So yeah, I would do things like this. I would have the homework problem, and then I would post it if the answer is correct in the code. It looks kind of ugly because it's not broken. I know maybe if we downloaded it and opened it in Jupyter Notebook, it would, but that's too much work. But I would go through like these calculus problems, but then I did really bad on the final test. because I didn't practice. I did more programming than handwriting. I thought like I get the correct answer either way. So that's kind of how I arrived at this. So if you want to check this out, um, it's on my GitHub, NSC9, and go to sample of work in the folder mathematics. So I have both these files here and some instructions. I'm using 1.2 SymPy. I think the newer version breaks, like there's some like floating point value that does not. Yeah, so that's why version control is kind of important. But yeah, if maybe you'll find value in this, just drill handwriting calculus problems. You can simplify this if you want. You can change this code. Let's say if you want to simplify it, you can change these. Like the integrals are by default more simple because if you're computing a lot of random composite functions and integrate them, it like gets really complex. You can do bigger stuff with derivatives, but the integral's a little harder. And at some point, it's just like computer does it so much better. It's like, why would you even handwrite integrals these days? But I don't know. If it's like piano playing, then maybe drilling the basics, handwriting them, it'll be, I don't know, it'll be useful somewhere. So we've got like a power function and square roots, cube root, ln's, logarithms, exponential, sine, cosine, and yeah. Don't know what else to say about this. I mean, it's been on my GitHub for a while, and I had it on Hugging Face, and Hugging Face broke. I had like a one-click thing, so but it just broke. So someone did fork it, and their version did work. Why is it? Yeah, someone did fork them. Okay, stop. Auto Plonsky. Okay, Plonsky. I was using his like environment. So that's the thing about these cloud computing platforms is it's one thing to code and deploy it. It's another thing to like maintain it because yeah, so it's not running anymore. His hardware is not running. This guy copied mine. Is it running for him? I don't think so. Yeah. But anyway, it was like this. Imagine this, but like one button, like a GUI button, you just click it and then it outputs all this. And it was kind of hard because it's like you need to make a Jupyter notebook interactive online and it has to refresh and get reloaded every time you click the button because it was kind of very tedious to maintain. I think I'm ranting though, so maybe I should stop the video. I think I made my points. Yeah, you can check it out for yourself. It's free and open source, GNU license, so you can edit it. You can DM me on X if you have any questions about the source code, which is math.py. And yeah, SymPy is awesome. So if you're a mathematics fan, you should definitely learn SymPy, which is a Python library. Oh, and one last thing. So if you go to the mathematics folder and you go to this, also, if you want the logarithmic functions, you don't have to take out this comment and just delete these two characters. It should work. That's up to you. Maybe I'll just edit that now. Think that'll be safe to do so. Hopefully it doesn't break for you guys. D main, that's the derivative main function. I main is the integral function. So let's commit these changes. You saw my email. I guess you can email me too. Okay. So yeah, this is a source code. So if you have any questions, ask away. I think I made a lot of this before ChatGPT. So this is like one of the prouder things I've done. It's kind of on my own. Yes and no. All right. I'm gonna end it now. So thanks for watching and hoped this is of value for you.